In this video, we just would like to discuss the use of logarithmic regression. So if I'm looking at two scatter plots, it's useful to know when I would need to use logarithmic regression or exponential regression. And it all has to do with the shape of the graph and if there is an intersection point on an axis, what axis that is intersecting. So let's look at the two graphs below. So we'll call this graph A, we'll call this graph B. If I look at graph A, and look at the shape of the data, I see a general trend upward, but also I notice that it's approaching the y-axis. So at some point, if we were to go back with a function, the function would also cross the y-axis. So that'll be important. Looking at function B, or scatter plot B, if I were to look at a function and model this type of data, again, I see a general trend upward, but the shape of the graph kind of stays away from the y-axis and approaches the x-axis. So if we think about the characteristics of an exponential function versus a logarithmic function, when I have y equals a outside of b to the x, we know that we'll have one y-intercept but no x-intercepts, and it looks like that this graph will produce a function like that. When I think about logarithmic functions, then we think of functions that don't intersect the y-axis, and most of the functions we've looked at, if not all, have intersected at approximately 1 on the x-axis, which looks like this data is going to do that. So for the first one, if we were going to find a regression curve, we would want to use exponential regression here. And over here we would want to use logarithmic regression.